Hello everyone, I am Suraj and here is the question of the day. So the question is the minimum recolors to get k consecutive black blocks. So in this question we are given a string block of length n in which each character is either W or B. W means the white color and B means black color. And we are also given an integer k which is the desired number of consecutive black blocks, which we will see what it is. And in one operation, what we can do, we can recolor a white block such that it becomes black block. Okay. And we need to return the minimum number of operation needed so that there is at least one occurrence of k consecutive black blocks. Okay. So let's see. So we are given a string block and also given a number k. So in this example, the k is 7. It means there should be consecutive blocks in which all the blocks should be black and the length of block should be this much. It means we need to see if there is any substring in this string which contains all the black characters and is of length k. We need to create such substring out of this string and we need to return the minimum operations to make such substring from this string, which means like this is the string and I need a substring of length 7 of all black box. Okay. So if we see there is 1, B, 2, 3, 4 and 5. If I put this W into B, this W into B and this W into B, so I will see that 1, 2, 3, 4, 5, 6, 7. I got 7 consecutive B means I got my answer, but is this the minimum number of operation I operate so that I am getting the consecutive 7 Bs. If there is any other options, let's take this one. If I'm converting all these Ws to B, I'm getting 7 Bs consecutively, but it is also 3 operations only. Let's say if in this I have to make 4 operations, so it is not my answer. So my answer for this question will be 3. But if we will just uh, go to each character and change and see either it is giving me the answer or not, this will be not an optimized solution. So we will see how we can do it in an optimized way. So first of all, what I will do is I will see the first k characters. In this case, it is 7. So I will see the first 7 characters and see how many W's are there, because if there are n W's, it means I need to perform n operations to make that substring to consecutive, to make that substring to k number of consecutive black blocks. In this case, there are 3 W's means I need 3 operations to convert this substring to a substring with all black blocks. So I will just count it. Let's say I am counting it. WC means white counts equals to 3 for this substring. It is my first substring. So what I will do now, I will move to the next step. I will see that how many operations I need to make this substring to a substring with all the black blocks. So there are 3 W's means I need 3 operations to make this substring to a substring with all black blocks. So in the second I need 3 also. Let's move next and see how many W's I need to change. So in this substring, there are 3 W's. It means we need 3 operations to convert this substring into a substring with all the black uh, blocks. So again, the next one is 3. Let's move ahead. And in this substring, I need 4 operations because there are 4 W's. It means I need 4 operations to convert this substring into a substring with all black blocks. So for next, it is 4. So it is the end because I don't have any characters after that. So I got 4 white counts: 3, 3, 3, and 4. And which is the minimum of these all? That is 3 only. So my answer for this question will be 3. And that was my actual answer. So what we will be doing it. First of all, we will count the number of W's in the first substring. So that is 3 only. So now what we are gonna do? We will just move our pointers ahead, both our pointers. And now we will be looking for this substring. So there are two things. First one, what is the character we just excluded, and what is the character we just included. So there can be 4 cases. Let's see what are those. The first one is the W is excluded and W is included. Then we will do something. If black is excluded and black is included, we will do something. We will see what we are going to do. And same with, okay. So let's see. In the first case, when we move to the second substring, we see that W is excluded and W is included. So if so what it shows that we need to subtract 1 W because 1 W is being excluded, and we need to add 1 W. So we will just add 1 W and subtract 1 W. So it will just give us the same thing only. So we will do nothing. Similarly now, so in WW case, we will do nothing. And if a B is included and a B is excluded, let's say if we move to the next part, in sorry, in this substring, what we did, we excluded a B and we included a B. So does it affects the number of W's in my substring? No, because the one which is being excluded is also W and the one which is being included is also W. So the number of W's will remain same, so nothing will happen. Now it is an important part. When the W which the character which is excluded is W, but the character which is being included is B. Let's exclude this one only. B. Let's say I was let's delete it first to make it clear. Let's say I was here and I moved. So in this case, the one I excluded is W and the one I included is B. So firstly, the number of W's in this substring were 3, but when I iterate to the next one, the number of W's becomes 2 because the one W got excluded. It means when the W is being excluded and B is being included, then we need to subtract by 1. Similarly, if the let's say there is W. Now in this case, let's say we move to the next step and see here the one which is being excluded is B and the one which is being included is W. So it means the number of W's in the range is being increased. So we will just add 1 to the W count. So I think it makes all the things clear. When there will be W and W, which means the character which is being excluded is also W and included is also W, then we will do nothing. Similarly, with the black one, if both are black, but if the exclusion one is W and the included one is B, then we will subtract by 1 because the number of W's will in that range will get reduced. And in the fourth case, when the excluded one is black and the included one is white, then we will just add 1 to the WC count. So I hope you understand this. So now let's dry run it. Okay. So what we are gonna do, we will be maintaining one more variable here, that is minimum. We are gonna return this minimum at the end. So we will initialize this minimum with WC only, because at first, at first, at first we will just give it the value of WC because it can be one of our possible solutions. If there is a solution which is minimum that which is minimal than it, then we will just update the minimum. So we just move ahead. So the one which is being excluded is W. The one which is being included is W. At WW, what we need to do is no change. So WC will remain 3 only and minimum will remain WC only. Next, the one which is being excluded is B and which is being included is also B. At BB, what we need to do is nothing. So WC will remain 3 only and minimum will also remain 3 only. Now, next, the one which got excluded is B, the one which got included is W. So at that case, we need to add 1. So it will be add 1 now become 4. Now if we will compare the minimum with that is, so minimum was, it was 3. Now it is being compared with WC, that is 4. Which is minimum? 3 or 4? 3 only. So minimum will remain 3 only. And now my string has been ended. So I will just return my minimum. So now let's code this. So first of all, what I'm gonna do is I need 2 pointers. The first pointer will be sorry. The first pointer will be here, and the second pointer is will be 0, 1, 2, 3, 4, 5, 6 here. But as I need to count the number of W's in it, so I will firstly put this counter here and move this counter by counting all the W's, and at the end it will come here. Let's see how I'm gonna do this. I will initialize first counter with 0 and second counter with 0 as well. Okay, so I need the WC. WC is the white counter. Second one is 0. Second will go ahead till it is less than k, and second plus plus. So we will see. We will just see that what is the character that is being stored at the second position. So if the character is a W, then do one thing, increment the WC. So till now, I got the value of WC till this time. I got W, the number of W's, that is 3. Okay. Now I need to create a minimum which I will be returning at the last and initialize it with WC. So my first pointer is here, my second pointer is here. Till how many steps I will move this pointer? Till the time it has not reached the end of my string. So what I will do, I will make a while loop. Thus, till the time second is less than the end of my string. Okay. Till then, what I will do, if I will take two characters, the first one is the one which is at the position of first. This one, this character, I will be storing in F, and second character. What is this S? This S is pointing to this character. Okay. So now what we are going to do is we will compare. Firstly, we know that if my this character the and this character is same, then we are not going to do anything. So first of all, we will put a condition. If these are not equal, then do something. Then do something. We will see what we are going to do. Okay. So now I know that my F and S are not same. So now there can be only two conditions. My F is W or my F is black. My F is white or my F is black. So let's see. If my F is white, then what I need to do is subtract by 1. If my F is black, then do something else. As there can be another option that F is white. If it is black, then add. Then just add it into my WC, that is white counter. And if it is white, then just subtract. Okay. And at the end, after each substring, I will just compare it with my minimum. So my minimum will be math dot minimum. What is the current value of my minimum, and what is the WC? WC is the white counter. And at the end, I will just return my minimum. So I hope it will work. It is taking. Okay. So I forgot to increment the values of first and second. That is why there was a time limit exceeded. Let's see. Yeah. So my test cases are accepted. Let's submit it. So yes, 92% beats. So it's quite a good solution. So that's all for today's video. Thank you.